All right, in this example, we are going to solve the following triangle. Triangle's been set up thusly. Now, first thing I want to do is organize my data. Because we've been given all three sides, this would be considered the side case of a triangle. So across from alpha will be side A. Across from beta will be side B. And across from gamma will be side C. This is dedicated to all of my Macomb students. Get it? Is it 586? All right. Sorry. All right, so we pose ourselves the question, do we have exactly two angles? The answer is no. Do we have a corresponding angle-side pair? The answer is no. All we have is a whole bunch of sides. Now, if all you have is the case of side, we're going to use the law of cosines. And we are going to use the law of cosines to find the biggest angle. Now, based on the structure of the three sides that I see here, biggest angle is going to be corresponding to the biggest side. That'll be b equals 8. So I'm going to use the version of the law of cosines where we can solve for beta. So that'll be b squared is equal to a squared plus c squared minus 2ac times the cosine of beta. Let's go ahead and plug everything in. So 8 squared is equal to 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of beta. Simplifying each of these things, 8 squared is 64. 5 squared is 25, 6 squared is 36, 25 and 36 make 61. 2 times 5 is 10, 10 times 6 is 60 times the cosine of beta. Do not try to combine these are not like terms. What we'll do instead is subtract the 61 from both sides. That'll give us positive 3 is equal to negative 60 times the cosine of beta. Taking this over here, this lets us know that the cosine of beta is going to be equal to negative 1/20. I now know, beyond a shadow of a doubt at this point, that beta is going to be an obtuse angle. Because the only way that the cosine of an angle can be negative is if the angle is a quadrant 2 or quadrant 3 angle. Because we're restricted to angles being between 0 degrees and 180 degrees, this is a quadrant 2 angle that is obtuse. So we'll apply an inverse cosine to negative 1/20, which will be approximately equal to For our final answer, we'll call that 92.87 degrees, but because we're going to likely have to reuse this for another calculation, I'm going to hold on to a couple extra decimal places. So again, in our final answer, we'll call this 92.87 degrees. Now at this point, you have a couple of options. What you could do is repeat what we just did, using the law of cosines to find either alpha or gamma. That is allowed. You also have a corresponding angle-side pair, and you could use the law of sines to find one of those other two angles. What I'd like to do is demonstrate that both of these will get you to the same result as I find the angle gamma. So, two ways that I could potentially find gamma. I could do sine of beta over b is equal to sine of gamma over c. Or I could set up the law of cosines using the c and gamma version. Now, doing a little bit of algebra here to shorten the process, multiply by c, we'll have 6 times the sine of, I'm going to use the version with a couple extra decimal places in here, divided by b, which was 8. Then we can apply an inverse sine to all of this. Now I'm not going to grab the calculator yet because I'm going to perform the necessary algebra for the law of cosines version as well, and then we'll do a comparison of our results. So plugging in things that we know, this will be 6 squared is equal to 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of gamma. This will be 36 is equal to 89 minus 80 times the cosine of gamma. Subtract 89 from both sides. Oh boy. Negative 53. Oh boy. Is equal to negative 80 times the cosine of gamma. So cosine of gamma is going to be equal to 53 over 80. Applying an arc cosine to both sides will give us our result. So what I'm going to do is perform both of these calculations in the calculator, and we'll compare their results. So first, the inverse cosine of 53 over 80. Okay, so this would be about 48.51 degrees. Let's try this one now. The inverse sine of, extra parentheses for the numerator, 6 times the sine of 92.8660, close the numerator, divided by 8. Fingers crossed, we're going to get the same thing. Oh my gosh, almost exactly the same thing. That's fantastic. So still 48.51 degrees. So please know on these problems that there are options. If you find something that doesn't, or excuse me, if you find something that does work, it does not necessarily mean that that is the only thing that you can do. Now, once you're to this point, to find alpha, I would recommend subtracting these two angles from 180 degrees. So alpha plus beta plus gamma is equal to 180 degrees, which lends itself to alpha is going to be 180 degrees minus beta minus gamma. So 180 degrees minus, we'll use the 2 decimal place version of these to get our alpha. So 180 degrees minus 92.87 degrees minus 48.51 degrees for a total of 38.62 degrees, rounded at the second decimal place. So, taking that back up top, that'll be 38.62 degrees, and that is our final answer.